Hi everyone, welcome to my video from this week's lab on projectile motion. What is projectile motion? A projectile is an object upon which the only force is gravity. Gravity acts to influence the vertical motion of the projectile, thus causing vertical acceleration. The horizontal motion of the projectile is the result of the tendency of any object in motion to remain in motion at constant velocity. This week's lab was focused on projectile motion, using a dart launched like a missile from a spring. The aim of the lab was to calculate the angle at which the dart was to be launched at to hit the set target. The distance between the target and the rocket would not be given until the demonstration had started, thereby being a variable for every group. Firstly, the maximum height the dart could reach had to be calculated. In order to calculate the initial velocity at which the dart was being launched at from ground level, the dart was launched 5 times to calculate an average maximum height of 140 centimeters. Further, this value was used to calculate the launch velocity v0 as shown. The diagram shows how the equipment was set up to calculate the maximum height. Here is a video of how it went down. Before angle could be calculated, the range equation had to be derived first. In general terms, range is equal to the horizontal velocity multiplied by time, shown through v times t equals r. Final velocity is equal to initial velocity plus acceleration multiplied by time. Initial velocity is positive sine theta. As the dart goes up, it's positive, and as it goes down, it's negative. Therefore, the final velocity being negative sine theta plus gravity times time. Therefore, t can be rearranged to equal 2v sine theta over g, as the horizontal range velocity is equal to v cos theta multiplied by the time. T can be substituted, therefore r equaling v cos theta times 2v sine theta over g. As trigonometric identities state, 2 sine theta cos theta equaling sine 2 theta, r can be known as v squared sine 2 theta over g. After all the values needed to calculate the angle were given / calculated, the horizontal distance formula had to be rearranged. An angle of 10.46 degrees was calculated, as shown in the calculations to hit the target. A margin of error and accuracy was calculated. In addition to the 1 meter given, our group added 0.05 centimeters to the range to calculate the differences in theta 1 and theta 2. Successfully, our dart had hit the target, as our calculations have proven to be correct. Here is a video of our dart hitting the target.